How's everybody doing today? How's it going, guys? Can you hear me? All right. So what we're going to do today is go through the worksheet that was posted on Canvas this morning. All right. So if we take a look, you guys should be able to find the net ionic equations worksheet. So what we're going to do is we're going to go through just the first couple questions together. And if you guys have questions, just let me know, all right? So you can just send me chats if you want to, or you can just pop up and ask questions, whatever you want to do. So we're just going to read through this together. It says when two solutions of an ionic compound are mixed, a solid is formed. This type of reaction is called the precipitation reaction. So you guys should know that when a solid was formed in a double replacement reaction, we make a precipitate. And the solid produced in this reaction is known as the precipitate. The precipitate can be predicted using the solubility charts as used earlier in the semester. For the precipitation reactions to occur on a product must be insoluble, which means it doesn't dissolve in water. And there are going to be three types of equations commonly written. So we've been doing the molecular equation since last semester. The molecular equation is just your balanced equation when you go from two reactants to two products and one of them created a solid. Then the second equation is going to be our complete ionic equation, which shows up as aqueous compounds. So the ones that have the AQ next to them, so the ones that dissolve in water, those ones are going to break apart the compounds so that we have each ion. So if we look at the example, they went from KCl, and they broke the K with the positive ions and the Cl's with the negative ions. They broke them apart into two separate things. Anything that we have as a solid or as a liquid, they can't break apart because they're not ions. They're solids. They're already compounds. The aqueous ones are ions, so the ions are just floating around all over the place. So they don't have to be, they're not stuck together right now. So that's why we can break them apart. And then one last thing that they want to note when we're talking about this is the fact that if you guys see that there's ions on both sides, those ions are called spectator ions. So if they don't help create the solid, they're called spectator ions, and we get to cross them out and create this new equation called the net ionic equation, only showing the compound, the ions that are used to create our solid or our liquid. So if we take a look at this example, see how they have two K's of the positive charge on both sides of this arrow. That means that they get canceled. There's the Cl ions on this side, but there's no Cl ions on the product side. So that's why those two Cl's stay down here. We have one lead with a +2 charge on the reactant side, and we don't have a lead ion on the product side, so that's why those two lead ions stayed. And because there were two sets of NO3 or two sets of nitrate on the reactant side, and now there are two sets of nitrate on the product side, those got canceled, and we're left with our final net ionic equation of just the Cl ions and the lead ion, making this lead chloride. Any questions on that information before we go ahead and do one together? All right. Sweet. Thank you. So if we take a look at our first problem, we have sodium chloride and lead 2 nitrate. So we write sodium chloride in our molecular equation. Do you guys know what sodium chloride is?
NaCl.
Perfect. NaCl. And then we have lead nitrate. Who can tell me what lead nitrate is?
Can't help you there.
All right. Lead 2 nitrate is going to be Pb for lead. Nitrate is NO3. And nitrate has a -1 charge, so that means that it's going to have 2 sets of nitrate for our 1 lead. So we have our reactants. Our products for this one. What is our Na going to bond with during this reaction? Nitrate, perfect. And so what is our lead going to bond with?
Chloride.
And for this one, it's going to be PbCl2, since chlorine has a -1 charge and lead has a +2 charge. Okay. The other thing we have to determine is aqueous, solid, liquid, or gas. So NaCl, does NaCl dissolve in water?
No. I don't know. Wait, not salt? Yeah.
Yes, table salt does dissolve in water, so it's aqueous. Give you a hint. You can look up above KCl for this one. Does lead nitrate dissolve in water? Did someone say no? Or did someone say yes? I'm going to tell you again that this one is also aqueous. So our 2 reactants are going to be aqueous in our 2 products. One of them is soluble. Which one is it going to be?
Sodium nitrate.
Is going to be aqueous or solid?
Solid.
Try one more time.
The liquid, the aqueous thing.
That one's going to be the aqueous one. We're going to have our lead chloride is going to be our solid here. So our lead 2 chloride is going to be our solid. So we have our equation. Now we have to balance it. Who could tell me my balanced equation?
Oh, 2 sodium chloride plus lead 2 nitrate, and then 2. Wait, what is that? Sodium nitrate plus lead chloride.
Like that?
I think. Wait, hold on. I'm not on the screen. Yeah.
All right. Anybody disagree, or does everybody agree? I'm going to go with everyone agrees since nobody said anything. All right. So we have our perfect balance equation. It's done. We're set to go. Now our next step is to create a complete ionic equation, which means any of your reactants or any of your products that you see as aqueous, we now have to break them apart and write them as ions. So is our first compound, our first reactant, is it aqueous or solid, liquid, or gas?
Aqueous.
It's aqueous, which means we're going to break it apart into its 2 separate ions. So how many sodiums do I have?
1 or 2.
We have 2 because we have 2 as our coefficient. So we have 2 sodiums. And what's my charge on my sodium atom? Does anybody know the charge normally on a sodium atom?
No.
Perfect. It is a +1. Thank you. So we have a +1 charge. So we're going to have 2 sodiums with a +1 charge. All right. And we're actually going to see how we have it up here. It says aqueous still. We are going to leave it as aqueous down here. So we got to put our aqueous part right here. Plus, we're not done because we have how many chlorine atoms?
2.
We have 2 chlorines. And what's the charge on the chlorine atom?
Ratio.
-1.
-1. Perfect. So we have a -1 charge here. And we're going to add aqueous again. So now we're done with breaking apart our first element or our first compound. So now we got to look at the next one of our reactants. We have lead nitrate. And did we say this was aqueous, or is this a solid, liquid, or gas?
Aqueous.
It's aqueous, which means do we break it apart or do we leave it together?
Break it apart.
We're going to break it apart. So how many leads do I have here?
2. Wait, no.
1.
I have 1 PB. I have 1 lead. And what's the charge on this lead?
2 plus 2.
+2. And this is aqueous. All right. And then our next one, our nitrate. How many nitrates do you have?
1.
So this
2.
one's a little bit, we have 2, and it's because this 2 right here tells us we have 2 sets of NO3. So we're going to have 2 NO3s. And what's the charge on my nitrate?
-1 or +1.
Perfect. -1. Nope, you're right the first time. And it's also aqueous, so we're going to put our AQ. And now we have our reactants. They're broken apart into their complete ionic equation. On the reactant side, we need to do the same thing to the product side. So we have to put our arrow, our yield sign, and now we do the same thing to our product side. So on our product side, our first compound on the product side, is this aqueous, or do we keep it together because it's a solid, liquid, or gas?
Aqueous.
It's aqueous, so that means we're going to break it apart. And so can anybody tell me one of the 2 ions that we're going to have from NaNO3?
Wait, what?
What's one of the ions that we're going to be left with when we break it apart?
Sodium and nitrate.
Perfect. And sodium, how many sodiums do we have?
2
And what's the charge on my sodium again?
+1.
And then nitrate. How many nitrates do we have?
2
What's the charge on nitrate?
-1.
-1. And then the last compound, PbCl2. Is it an ion, or is it aqueous, or do we keep it together?
We keep it together.
We're going to keep it together, so we're just going to rewrite PbCl2 right here. And we're going to leave it as a solid. And now we're done with writing our complete ionic equation. I know it looks long, but I think you guys can do it. All right, we have our complete ionic equation. Now we need to go from our complete ionic equation, we need to get to our net ionic equation, which means that we need to find anything that is the same on both sides, and it's going to go away. So if I look, Na, do we have 2 NAs on both sides? Is there a 2 Na with a 2 sodium atoms, ions with a +1 charge on our product side?
Yeah.
Yeah.
Yes. So if we have it on both sides, they're going to cancel out. So they're going to go away. Now, if we look, do we have 2 chlorine ions on both sides?
No.
No, there's no chlorine ion on the other side of our equation. So what we're going to do is we're going to take that chlorine and we're just going to put it down here on our net ionic equation. So we're going to take our chlorine, we're putting it on our net ionic equation. So we're going to put the 2 Cl's with the -1 charge in aqueous form right here. And then we're going to keep going. So our next step is to look at our leads. Do we have a lead ion on the product side?
No.
We don't have a lead ion, so we're going to take the same thing. We're going to bring it down to here. So we're going to add our 1 lead ion with a +2 charge in aqueous form. Put it right here. And now we're going to keep going with our equation again. Hold on. Sorry. There we go. All right. So now let's look. Do we have 2 nitrate ions on our product side?
Yes.
We do. So these 2 nitrate ions are going to go away. We're going to cancel them out. And we're done with our reactant side. So now whatever is left on our product side needs to be on our product side of our net ionic equation. So what's left on my product side?
Lead.
Lead chloride. Perfect. So now you can see that our net ionic equation is really just showing us how to create our solid, getting rid of anything that doesn't get used up during the reaction. It stays as an ion. So these are only the things that are going from ions and forming that solid. Any questions on this one? Do you guys want to do another one together?
Sure.
Sure. Okay. So we take a look. I'm just going to change colors again. So we're starting with sodium carbonate and iron 2 chloride. Sodium is what element symbol?
Na.
Na. And carbonate is what polyatomic ion?
CO.
CO3. And if I write my sodium carbonate, do I need more sodiums? If we write out the charges, what's the charge on sodium?
1.
+1. What's the charge on carbonate?
2.
-2. So my formula here is going to be what?
Na2CO3.
Perfect. Okay. Iron 2 chloride. Iron is what element symbol?
Fe.
Fe. And it has what charge here?
2.
Chloride is what element symbol?
CO.
And it has what charge?
1.
All right. So my final formula here is going to be what?
Na2CO3 plus FeCl2.
Perfect. Sorry, just trying to move it. Plus FeCl2. And so if we look at these, we're going to find out that both of these are aqueous. From our solubility chart. And if we keep going, we need to create 2 new compounds with our double replacement reaction. So how are we going to create 2 new compounds? Anybody tell me one of those two new compounds?
Sodium chloride.
Sodium chloride. So what's
And
the other one going to be?
iron carbonate.
Iron carbonate. All right. And then which one of these is going to be aqueous?
Salt.
Salt is going to be aqueous, the sodium chloride. Which means that iron carbonate is going to be a
Solid.
solid. Perfect. All right. Now we need to balance our equation.
We don't have to do anything with the reactants, but we have to make Na chloride 2.
All right. Everybody agree?
Mm-hmm.
All right. So now our next step is to create our complete ionic equation, which means that anything that's an aqueous needs to be broken apart into its ions. So is sodium carbonate, is that an aqueous solution?
Yeah.
All right. So we need to break it apart into its two ions. What two ions are we going to be left with?
Sodium and carbonate.
All right. And we have sodium. And what's the charge on sodium?
+1.
+1. And how many sodium ions do we have?
2.
We have two of them. 2 sodium ions. Carbonate has what charge?
+2 or -2.
-2. And do we have more than one carbonate?
No.
Nope, we just have the one, and it's an aqueous solution as well. Now we look at our next compound, iron chloride. Is that aqueous or is that a solid?
Aqueous.
Aqueous.
It's aqueous, which means that we have to break it apart into its two ions. What's the first ion that we're going to break it apart into?
Iron plus chloride.
Iron plus chloride. All right, and my iron has what charge?
+2.
+2. Do I have more than one iron?
No.
Nope, I just have the one, so I leave it as 1. What about my chlorine ion? Do I have
Yeah.
more than one? How many?
2.
I have 2 chlorines. And what's the charge on my chlorine?
-1.
-1. All right. Now on my product side, is NaCl aqueous or is that a solid?
Aqueous.
It's aqueous, which means we have to break it apart into its two ions. What's my first ion?
Sodium.
Perfect. How many do I have?
2.
What's the charge?
+1.
+1. What's the other ion?
Chloride.
Chlorine. How many do I have?
2.
I have 2 chlorines. There's the 2 distributes in the both. And what's my charge on chlorine?
-1.
-1. And it's also an aqueous solution. All right. Now our last product, iron carbonate. Is it aqueous or is it a solid?
Solid.
It's a solid, so we're going to leave iron carbonate as iron carbonate as a solid. We're going to leave it alone. All right. So now, if we take a look, we have our complete ionic equation. So now what we're going to do is we are going to find anything that's the exact same on both sides. So if I look, do I have 2 sodium ions on both sides?
Yes.
Yes.
You do. So we're going to take our 2 sodiums from both sides and we're going to get rid of them. What about carbonate? Do I have a carbonate ion on my product side?
No.
No.
No. So I'm going to take that, comes part of my net ionic equation as CO3 with its -2 charge in the aqueous form. All right, now I take a look at my next one. Do I have an iron ion on both sides?
No.
No.
No, I do not. So I'm going to bring that down here. So I'm going to add my iron ion to my reactant side. What about 2 chlorine ions? Do I have 2 chlorine ions on both sides?
Yes.
I do. So I'm going to take my 2 chlorine ions and I'm going to cancel them, get rid of them because they didn't get involved in our reaction. And now all my reactants are done. So now what is my product going to be?
Iron carbonate.
Iron carbonate. And we can see that we have 1 carbonate ion and 1 iron ion. That makes 1 set of FeCO3. Just remember that anything that's aqueous, that means that it's dissolved, which means that the ions, the positive and negative ions, are just floating around anywhere. So that's why our reaction happens, is because those ions aren't matched up with anything anymore. They're not locked into place. They're just floating around all over the liquid, all in between the water molecules, which is why we can form those new bonds, is because the bonds are not holding our ions together anymore. Are there any other questions with this stuff?
No.
No.
No? Anybody have questions about anything they've been doing last week?
No.
No?
Can you put a solubility chart on Canvas?
Yeah, I'll get that right now.
Okay.
Anybody else?
No.
Nope.
No? All right. I think that was our entire meeting. What I'm going to do is I'm going to take this, I'm going to save it and put it on Canvas so you guys can go back to the recording if you wanted to go back and look at it again, or if you just wanted to see the answers. The whole answer key for this entire worksheet will be posted tomorrow for you, so you'll be able to see the entire worksheet tomorrow.
Okay. So today's e-learning is to finish the rest of this sheet.
If you want, I would say at least do 1 more on your own. So, because I don't want you guys to go way over your time limit of 25 to 30 minutes. So if you want to do at least 1 more on your own, that'd be great. But you don't have to get through the entire worksheet because there's 9 problems, and I feel like that's just too many to do unless you want to for the 25 minutes. So I think, or 8, there's 6 more problems. So if you want to do 1 or 2 more, that's great. If you want to turn it in as is, I'll accept it. If you want to do all 8 problems, that's great. It's good practice for you. But the requirement is only going to be like through problem 3.
All right.
Any other questions?
No, sir.
No? All right. I think we're done then, ladies and gentlemen. Have a great rest of your day. And if you want to join tomorrow, what did we say? Between, I think it was 11 and 11:30, right?
Yeah.
Perfect. If you guys want to come in tomorrow, you can. If not, you guys are good.
All right.
All right.
Bye.
Bye, guys.
See ya.
See ya.
Oh, no. No, right now.